This is our review of our pre-calculus second 6 weeks final for the fall of 2015. And we had 23 problems on this test. And in this review, I'm going to go over 11 of those 23 problems, some of the more difficult problems on this test. Problem number 20, a car you're thinking of buying for $20,000 is expected to depreciate in value at a rate of 15% per year. Which function best models the value of the car as a function of time, t, in years? Well, I kind of misworded that, but that's all right. We have the basic formula is P, which is a finishing amount starts at the initial principal or value of quantity 1 plus r to the power of t. And r is equal to our rate. And if we're going to depreciate in value, the basic formula is 1 plus r. So in this case, r is going to be equal to depreciating at 15% per year. So we're going to make this r as negative 15%, which in decimalized form is going to be negative 0.15, or sometimes you can write 0.15. So to use our function, we're going to have our principal, P, is equal to our starting value of the car, which is $20,000, times 1, and it's going to be plus r, so that's going to be minus 0.15 to the power of t. And simplifying this 1 minus 0.15, we have P is equal to 20,000, and the answer choices have a V, but that really doesn't matter. We have 0.85 or 0.85 to the power of t. So D is our correct answer to problem number 20. And by the way, these problems are not in particular order, so you're going to have to kind of flip through your tests in different places. The next problem we're going to look at is problem 3. What are the real zeros of the rational function shown below? We have this rational function 2x plus 12 over x equals 11. We could solve this problem by clearing the denominator by multiplying by x, and then just kind of simplify till we get our answers. But I'm going to recommend for this doing something different, which is solving by graphing, which we call using the x-intercept method. And to do that, we're going to rewrite this equation here as 2x plus 12 over x, and we're going to subtract 11 from both sides of this equation, original equation, and so we have 2x plus 12x minus 11 is equal to 0. And now we can graph this function as f of x equals 2x plus 12 over x minus 11. And we do that, we can see, we hope, where the function, the graph function, touches the x-axis, and that will let us know what our real solutions are. So we go back to our calculator, and I've previously entered the functions here. So I go up to this one, and this is that 2x plus 12 over x minus 11. And we graph the function, and we see that we have two places the graph function touches the x-axis, between 1 and 2, and at x equals 4. And we go back to our answer choices, and we see the only place that we have these answers is at answer letter B. So that'll be our answer for this. Now, problem 5, which is similar to problem 3, but really more complicated in that we have the rational function below as a real solution of x equals negative 5. The equation in its solution has an extraneous 0. What is the value of the extraneous 0? What is an extraneous 0? Well, an extraneous 0 equals a 0, a solution that is created in or during the process of solving. An equation. And it so happens that extraneous solutions can be created in solving rational equations and also in solving logarithmic equations. So in order to solve this, we're going to do what I suggested earlier for problem 3, that is to clear the denominator. 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 So we're going to multiply this whole equation by this factors of quantity x plus 2 times quantity x minus 3. Well, where did I get these two factors? So I got them from the denominators on the left side. We have x over x plus 2 and 5 over x minus 3. So we're going to clear out that denominator. It so happens that quantity x plus 2 times quantity x minus 3 is also equal to this x squared minus x minus 6. And so multiplying everything out, I'm going to bring down here below our answer choices. And we have x times quantity x plus 2 times quantity x minus 3 over x plus 2. Then we have plus 5 times quantity x plus 2 times quantity x minus 3 over, we have x minus 3. And now on the right side of the equation, we have 25 quantity x plus 2 times quantity x minus 3. And this goes over this x squared minus x. So minus sign there, minus x. Rewrite this a little bit. X squared minus x minus 6. And since quantity x plus 2 and quantity x minus 3 are factors of x squared minus x minus 6, we can cancel all these out. And in the middle term, we have x minus 3 over x minus 3 cancel each other. On the right term, on the far left term, we have x plus 2 over x plus 2 cancel each other. So writing what we have left, we have x times x left. So we have x squared. And then we have x times negative 3 is going to be minus 3x. And then we have on this right here, 5 times x, distributing 5 and x, we have plus 5x. And then we have 5 times 2, which is plus 10. And on the right side, we just have 25 left. So we're going to try a couple of simultaneous steps here. We're going to take x squared, and negative 3x plus 5x is going to be plus 2x. And then we're going to subtract 15 from both, subtract 25 from both sides of the equation. So 10 minus 25 is going to be minus 15. And on the right side, we have 25 minus 25, which equals 0. And so now we can solve by factoring here. We have 0 equals the two factors here of quantity x plus 5 times quantity x minus 3. And finding our solutions, if we set x plus 5 equal to 0 and x minus 3 equal to 0, we get our solutions x equals negative 5. Well, we already know x equals negative 5 is our real solution, but x equals 3 is what we call an extraneous solution. An extraneous solution. So what that enables us to do is answer the question. We circle our answer choice C. And there's some techniques. You can kind of look for what makes the denominators 0. In this case, negative 2, answer choice B, can make the denominator 0. Or in this middle term here, x minus 3, that denominator could be 0 if x is 3. And so if you had to guess based on that, you'd be choosing between C and B. But C is the correct answer. 19, during 15 years, an initial investment of $10,000 grew to become $31,722. What was the average annual growth rate of the investment? Well, that's kind of back at that problem we were looking at earlier with the depreciation. It's going to be P equals P sub 0 times 1 plus R to the power of T. In this case, R is going to be equal to, it's going to be a percentage. We don't know what R is, but we know everything else. We know our final value is $31,722, and we know that our initial investment is $10,000, and we have 1 plus what we don't know is R, and we know the time, 15 years, so the power of 15. So we could divide by 10,000, and so we get 0.1 plus R to the 15th power, take the 15th root, and so forth. But this one, I'm going to suggest using in our calculator something we call numerical solve. Numerical solve, or sometimes called nsolve. Okay, to do this, go to our calculator. I'm going to put Control I. Control I, and get a calculator page, and we're going to go to numerical solve, menu, 3 algebra, numerical solve. I'm going to put 31,722, I think that's the amount, is equal to, we take our equal sign here, we take 10,000 times, sometimes we have to use a multiplication sign, we have 1 plus R, which we're going to call as X, to the power of, we're interested in 15 years, so the power of 15. And then we're going to put comma X. And we press our button, we get 0.080001. So 0.08. So R is equal to 0.08, which equals 8%. And our correct answer is B. We could have plugged in to this formula a value of R until we ended up equaling 31,722. But this numerical solve is really a good way to do this type of problem. If we do it quickly, we can save a lot of time for other problems that are going to be more prickly for us. The 21, the current world population in 2015 is estimated to be 7.3 billion people. The world's population continues to grow at a rate of 1.1% per year over the next 10 years. What would you expect the world's population to be in 10 years from now in 2025? Well, it's the same thing we've been doing earlier. P equals our starting value, P sub 0, of 1 plus R to the power of T. Well, in this case, R is going to be equal to 1.1%. which equals in decimalized form 0.011%. So that's going to be our value of R. Now we can just plug into this equation. So P is equal to 7.3 as in billion, and 1 plus 0.011 to the power of how many? It's 10 years? 10. So we have P is equal to 7.3 times 1.011 to the power of 10. And now going to our calculator, we just put in 7.3 times I'm working on a video right now, 1.011 to the power of 10, and we get 8.14394. So 8.14394, which most closely approximates this one, answer B. Next one, rewrite the logarithmic equation below in exponential form. And so for this, we're just going to take the base of the logarithm, which is 4, and kind of do a switcheroo. We're going to move that x over here to the right and the 6 over here to the left. So we're going to have 4 to the power of 6 is equal to x. And so our correct answer is C. That should have been a pretty easy problem. Next, 6. A negative polynomial function f of x of degree 3 has three distinct zeros of x equals -1, x equals 2, and x equals 4. The domain of f of x is all real numbers. Over what intervals is the value of the function greater than 0? So for this, we have to go back to our understanding of polynomial functions. And that is, first of all, we have the domain of polynomial functions is all real numbers. And so just creating an x, y coordinate plane, if we go look at where our zeros are and just mark them at x equals -1, which I mark here, and x equals 2 on the right side of the y-axis, and at x equals 4. So those are the zeros that are given to us, and we have a degree 3, and we have 3 distinct zeros. So each zero has a multiplicity of only 1. And this is a negative polynomial function, and a negative polynomial function will start high. So I'm going to say starts high on the left and ends low on the right. And so just sketching this out, from the left, we're going to come down through x equals -1, kind of go around down here and come back up through, touching in through x equals 2, coming back up and then coming back down and touching where x equals, make a little bit more representative graph. That's going to be more, it's going to look more like it. Touches x equals 4 and then continues on down like this. So that's sort of a diagrammatic. It's not to scale, but we're saying at what intervals is the value of the function greater than 0? So we have to look above the x-axis. And so if we just kind of box in here above the x-axis like I'm doing here in blue, okay, any place we see the graph above this x-axis, what I boxed in blue, that's going to be our solution. So we come from greater than -infinity all the way to -1. That's above 0, and also between 2 and 4. Our correct answer is A. Had a lot of people who pick C as a correct answer. Well, C would be the correct answer if we had a positive cubic function, which I'm now drawing in blue. See that? But the red one is the true one, so therefore A is the correct answer. Problem number 7, rewrite the 3 logarithms below as a single logarithm. So we use basically our rules of logarithms. First of all, we have the rule of exponents. So this 3 in that first logarithm is going to come out as a power of that first term here. And the second one, we have this 1/2 is going to be the power of y. For the third one, we have this 2 of this power of z. So rewriting this expression, we would have log base 3 of x to the third power, and we would have plus log base 3 of, we're going to have y to the 1/2 power, which is going to be the same as square root of y, and then we're going to have minus, we'll have logarithm base 3 of z to the power of 2. And then what we'd have here is, writing as a single logarithm, we would have the log base 3 of the product of x to the third power times x to the 1/2 power, which is the square root of, y, square root of y, which is y to the 1/2 power, over z squared. And we have z squared because we have minus that logarithm. So here we are, and this will be our correct answer, which we find answer choice D. Next problem, what is the logarithm of 1 over 10,000? And for this, if we set this, basically what we're being asked here is we have log, rhythm log is log base 10 of 1 over square root of 1,000 is equal to x. So just rewriting this equation as an exponential equation, we would have the base of the logarithm is going to be the base of our exponent. So 10 to the power of x is going to be equal to 1 over square root of 1,000. And so what we have here is we can rewrite this on the right as 1 over, we can write 1,000 is 10 to the third power, and we make that, the square root of that, to the 1/2 power. And that's in the power position. It's not maybe quite exactly legible. I'm going to leave myself a little more room. Okay, we have 10 to the third power to the power of 1/2. And we have 10 to the power of x is equal to 1 over 10 to the power of 3/2. Well, we can rewrite that as 10 to the power of x equals 10 to the power of negative 3 over 2. And we can see what that answer is, right? A. And we could also just put this in our calculator. And for that, in our calculator, we would say control log log base 10. Log is log base 10 of the fraction 1 over square root of 1,000. And we get for that negative 1.5, which is negative 3 over 2. We got it already without a calculator. There it is, answer choice A. Next problem we have is for the polynomial function g of x below, there are 4 distinct real zeros. What is the largest multiplicity of the 4 zeros? Mark your answer in the grid provided. Well, here are the zeros. We have the first zero we see, if we have x, we set that equals 0, we have x is equal to 0. And next we have x is equal to 5. And then the next one we have is x is equal to negative 1. And the last one we have is x is equal to 2. As far as the multiplicity of the zeros, well, this 0 at x occurs only once. So there's going to be this first one here, x equals 0 is multiplicity is equal to 1. X equals 5, that's a multiplicity equal to 2. This x equals negative 1, that's a multiplicity equal to 1. And this x equals 2, we have 20x minus 2 to the third power. So this is going to be multiplicity equals 3. And just what we're going to do is we have these multiplicities I'm now circling in red. This 1 here, this 2, this 1, and this 3. And so it says, what is the largest multiplicity of 4 zeros? So I take these numbers, 1, 2, 1, and 3, and see which is the largest of those numbers. Well, the largest number is going to be 3. So we mark in our answer as plus 3. Okay, there it is, plus 3. That's going to be plus 3, plus 3. And we mark this in right here. And it marks, I'm going to clear up, kind of wrote over the answer sheet, the bubble. But that's our answer right there. Should have been pretty easy. Okay, the last one we're going to be looking at is problem 23. After simplifying the exponential expression, 20x to the fourth y squared, and that to the third power times y to the third power over x to the negative fifth, what will be the power of x in the simplified expression? For this, we have, I'm just going to rewrite this down here, we have x to the fourth, y squared to the third, and then we have y to the third power over x to the negative fifth. Okay, for this, we're going to kind of distribute, and we could do this different ways, so that x to the fourth raised to the power of third becomes x to the 12th power, and the y squared raised to the power of 3 is equal to y to the 6th power, and then we bring over what we have left, which you have y to the third power over x to the negative 5 power. Okay, so what we have here, just kind of combining things, we have x to the 12th, and then we have y to the 6th times y to the 3rd power is going to be y to the 9th power, and then we have this over x to the negative 5th power. Well, what we have is the answer for the power of x is going to be x to the 12 minus negative 5, which equals x to the 12 plus 5, which equals x to the power of 17. So our correct answer is plus 17. Here's the 1 here, and the 7 is down here. So those are what your correct answers on those 11 problems should look like. Good luck to you on your review for your upcoming tests and opportunities, and thanks for viewing.